Now this sounds like a line from a Dire Straits song, but I love my FTPs. Yeah, I especially like my side lights. I've had these really bright side lights for yonks now. So in 2020, right at the end of 2020, can we still get the right LEDs to produce a really nice side light on the FTPs? And how do you get them error free? Because if you don't work with it right, that's right, you tell them, Pippi, go on. What do you say? Yeah, he says you've got to put a PTC device on there, positive temperature coefficient device on there, and then you won't get error messages. Actually, you can have these without the PTCs and still not get error messages, and I'll show you how to do it. But it's not the way I've gone. I've fitted PTCs. Anyway, let's get on with it. Hello and welcome to Timm's BMW Repairs and Information. Yes, I love my FTPs and I love them because they're really bright and white. And look at this, my side light is almost bright as the main beam. Yeah, in the UK we use the main beam when the stalks press forward and we're driving at night. And these FTP main beams bung a focused amount of light right down the centre of the road. It really chucks it into the distance. It's very useful. Of course, in the US, they're only used to flash, which is why they're called FTPs, flash to pass, which is what they're used for. And when you put your main beams on, they don't come on. Anyway, beside that, yeah, my side lights, I love the side lights, and they can be used as daylight running lights, because they're about as bright as a 40-watt halogen, around about there. Right, so this episode is all about the side lights. The next episode is about the main beams. And now I'm going to spend 10 minutes telling you the problems of using LEDs in old BMWs and why you get so many errors with them. You get cold bulb errors, hot bulb errors, and all sorts of problems like that. And so we can go through that. And then after that, I'll go through exact modifications to this on the back of it to make it completely error-free. And so it's completely transparent. It works just like a tungsten bulb, but it's 10 times brighter. And you don't get any error messages. And of course, it uses a lot less electricity. Yeah, and nothing to do with CANBUS, by the way. CANBUS wasn't even in, oh, it was used in the E31, but only between the engine and the gearbox. So CANBUS errors, that's a bit of a misnomer. So anyway, yeah, we got three choices with this LED. Now, this is a brand new LED from Amazon. Cost me about £5 or £6 for a pair of them. I'll put the link up in the description. So yeah, we've got three choices here. One, we can just take the tungsten bulb out, stick this in. Now you get a reasonable amount of light out of it, but not as bright as this side light is. And of course you'll get errors on the dashboard as well. You get side light fail, which is pretty annoying. Now, the first mod we could do to it will increase its brightness significantly, and you only get cold bulb errors. And if you get in the car and turn the side lights on before turning the key, then you don't get any errors at all. That's quite a useful thing to do. But I don't like errors at any point. So if you failed to switch the side lights on before we turn the ignition on, you'd still get a cold bulb error, say a side light failure. So the second mod, which is on the back of this, then modifies it so that it passes the hot and the cold bulb test. And is perfect. So there's your choices. Feeble amount of light by just swapping it. Lots more light. Or do it properly with the hot and cold bulb failures sorted out. Now I'll be showing you exactly how to do the soldering on it. I've done it already. It's pretty straightforward. And if I can do it, anyone can do it. Yeah, just take your time and do it. Now, if you like, just go forward 10 minutes or something to that point where I'm beetling away with my soldering iron, or you can hang around and I'll tell you all the problems and why you have to do modifications to LEDs, what the wattage means, what the lumens mean, what does CANBUS error-free mean. Doesn't mean anything. I'll tell you that for nothing. Yeah, and I can go through all of that and I can tell you why LEDs are so hard to use on the old BMWs. So yeah, if you don't want to know, just go forward 10 minutes. Right, let's switch this light off. I can't see out of my left eye anymore, by the way, but there you go. Anyway, if we go right back to the start, I'll have to reconfigure my wiring here. Yeah, tungsten lights. Yeah, they're peculiar things because, as you know, they're just a coil of tungsten wire in an evacuated glass tube. That's all there is to them. And the elements are wound so that they get extremely hot and give off a lot of light. And it's a secondary thing, the light is. The main thing that comes out of a tungsten light is heat. Yeah, they radiate a lot of heat, as I showed on the front of my car earlier on. Yeah, so they dissipate all their energy, well, most of it, 95%, if not more, as heat. And the last 5% gets turned into light. And it's pretty obvious when you think about it, because you're just heating up a coil of wire. And so, yeah, they get extremely hot, take a reasonable amount of current. So here's a tungsten bulb. Now, I can't find a 521 watt, which is what's used in our FTPs. But I've got a 21 watt bulb here. And we can have a look at how much current one of these takes. And then we can talk about the wattage. Okay, so it's a 21 watt bulb. So that's 1.8 amps at around about 12 volts. So yeah, 1.8 times 12 is about 21 or so. So that's a 21 watt bulb. And it's straightforward because that's the amount of energy that it dissipates. 1.8 amps times 12, 21 watts. Straightforward and simple. And we know about watts because, of course, the ceiling bulbs, they've got wattages on them. And in the old tungsten days, we knew a 40 watt bulb, you could hardly see a thing. And a 60 watt bulb, yeah, it's getting closer. 100 watt bulb, yeah, that's probably the one. That's about what's illuminating my workshop here. So we knew about what a wattage is, and we knew that 21 watts was reasonably bright, and we knew that 5 watts was very feeble, and it was very simple to work out. Now, along came cold cathode fluorescent lighting, and of course they bunged out twice as much light for a given wattage. The power watt is a unit of power. So we talk about power, put the same power into a CCFL lamp as you do with a tungsten lamp, and the CCFL will give out twice as much light. So now it got a bit difficult talking about wattages, but we ignored that until LEDs turned up. And then, of course, LED manufacturers didn't want to say, well, I've made a 20 watt bulb. Well done, mate, that's not going to do anything, is it? No. So what they tried to say was, of course, their 20 watt bulb was as bright as a 100 watt bulb. Okay, that's fair enough. Don't call it a wattage. It's as simple as that. Start talking in lumens. So a 100 watt tungsten bulb gives out probably about 50, about 500 lumens or so, something around that, 100 watts. And so if you got, for instance, an LED bulb that bunged out 500 lumens, then they could say, what they were saying, well, it's equivalent to 100 watts. So they put 100 watts on the box, which of course they weren't, because they took much less current. And so they actually were 20 watt bulbs, but bunged out 500 lumens. And recently, of course, things have changed slightly. So instead of talking wattages, they now talk lumens, so you've got a better idea of what's going on. Now with car bulbs, they make it all up. I mean, that's the bottom line. They just make up figures, they lie. As simple as that, they just lie all the time about it. So this bulb, for instance, oh no, it's not that one. I've got another one here somewhere. Yeah, this is for the main beam. I bung you up there. So that is meant to be an H3 bulb, which fits directly into our FTP for the main beam. They say that's 160 watts. That's what it says on their information. Interestingly enough, on the box they don't mention wattages or anything, because you've now got hard evidence. But no, on the advert it says that's a 160 watt bulb. And that's just lying. It's lying for two reasons. First of all, it doesn't bung out the equivalent light that a 160 watt halogen would, nowhere near it. And it actually takes 5 watts. Yeah, 5 watts, not 160 watts, nowhere near it. 5 watts and about 500 lumens. Compared to an H1 or an H3 Osram light breaker, They bang out something close to 1500 lumens, but they dissipate 55 watts. Okay, so lies, damn lies, and LED specifications. Yet they just make it up. I wish they wouldn't. But anyway, here's my LED that I bought from Amazon for our side lights. They didn't make any lies about that. They said it was 6 watts and it takes the place of a 5 watt, 21 watt bulb. So that's very generous of them, thank you. They've actually called it a 6 watt bulb and it is actually 6 watts. And we can actually measure the amount of current that it takes. And so I can stick it on here. You won't be able to see the meter, and I'm not using 2 cameras today. So there we go. Coming down to about 500 milliamps. So yeah, around about 6 watts. So yeah, thank you very much to the people who made those. They don't say on the box, but it's X0011XK431. I'll put the link up in the description. But thank you. Yeah, you've given the right information. I don't think they mentioned the lumens anywhere, but there's a quick mathematical formula you can use to tell how bright an LED is. And that's you just multiply the wattage by around about 150. And we're being generous with 150 because only the very, very best LED die give out 150 lumens per watt. These probably give about 100 or so. So we're talking 600 lumens. Well, that's not bad at all for a little bulb. And I'd be quite happy if they put 600 lumens on the box, or they put the equivalent wattage, although that's now miles out. So you could actually say, makers could say, that is a 100 watt side light bulb, because it bungs out the equivalent to a tungsten 100 watt bulb. But unfortunately they don't. They just say it's a 6 watt bulb, and from that we can say, well, it's probably about 500 lumens. And that's almost as bright as one of the cheap H3 or H1 tungsten bulbs, which isn't a night breaker or something like that, a really cheap one. So yeah, I mean, that bungs out a lot of light. Now, that's enough blurb, I think, about lumens and stuff. We'll talk a bit more about that fella when we do the main beams, but that's just big lies. You know, everything's made up about that. It takes 5 watts. And yeah, 5, 1.5 about, oh, God knows, tiny amount of lumens. So it's 3 times dimmer than a halogen Osram night breaker, for instance. But they call it 160. I'm going to keep going on about this. It's ridiculous. 160 watt, my arm. Yeah, okay. Anyway, very happy with this LED, and I was worried we couldn't get these anymore right at the end of 2020, because I did this modification to the FTPs a very long time ago. And these were just coming out, the metal cased ones. In fact, I've got one here. That's a metal cased one from 2010 or something around like that. They're quite long. And we've got to be careful with LEDs because you've only got a certain amount of depth before they hit the internal structure of the FTP. So yeah, this is perfect, which is why I put the link in the description. This is exactly what we need. Bungs out a lot of light, takes the right amount of current when it's actually running. Okay, rightio, so that's that section done with wattages and lumens. Now we talk about tungsten bulbs and error messages, because it's on our old BMWs, it uses 2 methods of testing. It does a hot bulb test and a cold bulb test. Hot bulb test, it makes while the light is running. All it has to do is measure the current that it's demanding. And if it's demanding, you know, a few milliamps or so, a few hundred milliamps, then they say, yep, that tungsten bulb is running. And of course, we're only talking about 5 watts in the side light. That's what was put in as standard. Yeah, the 521 watt bulbs, which I pretend that is, and it would have 2 doofers on the bottom of it. We actually only use the 5 watt terminal and not the 21 watt. So it's a 5 watt bulb, and the lamp control module just sees a couple of 100 milliamps and says, yep, that bulb is working. Now, what it needs to also test is, before you actually start driving off in your car, it wants to make sure the bulb is going to work once you've got 100 yards up the road. So what it does is it tests it while it's off. And what it does is it just puts a very quick voltage up it. So a quick blip of voltage, not long enough to make the bulb illuminate. Okay, that's quite important, because then people start thinking you're flashing them or something, which is why the main beams don't have any LKM testing on it, because they don't want them ever to flash, in which case the oncoming driver will pull out in front of you. And they don't want the indicators to flash while they're doing a cold bulb test, so they're not cold bulb tested either. Bit of trivia for you. Okay, so 5 watts, a couple of 100 milliamps, that's all it expects for a hot bulb test. Cold bulb test sticks a tiny bit of voltage in very sharply and then checks how much current. Well, how much, we know from our test just now, this was 1.8 amps that this bulb takes. How much current do you think it takes when you put just a little blip of voltage up it? A lot more than you expect, not 1.8 amps. So what we do is we'll put this meter into, I'll get the range right to start with. There we go, that's the right range. And then peak hold. It'll beep at me for a little while. And what I do is I'll keep the positive on here and just flash the negative across. Okay. Ready? There we go. Yeah, my meter's gone off the end of the scale. It's actually over 10 amps that it takes. Yeah, it's absolutely amazing. Yeah, well, it reckons 7.7 amps now. So let's try that again. I think it's going to go off the end of the scale again. Might be better to do it with a 10 watt bulb. Oh, here we go. I'm going to flash across. So the bulb didn't illuminate. Yeah, we're off the end of the scale. So 21 watt bulb, probably not the best thing to use there. So unpeak it. This time we'll use a tiny little 10 watt bulb, which takes about 800 milliamps when it's running. What does it take when you just blip power into it? 6.4 amps. Yeah, it's very surprising, isn't it? And the reason for that is it is just a little coil of wire, and when it's cold, its resistance is very low and it takes huge amounts of current, which is why the early sort of theatre triac controlled lighting used to blow itself up every 5 minutes. Yeah, tungsten bulb takes a surprising amount of current when they're not switched on. Now, when they warm up, of course, the current slowly reduces to what the correct current is for these bulbs, which 10 watt bulbs, about 800 milliamps or so. 0.8 times 12. Yeah, that's close enough. 0.8 times 12. So yeah, 800 milliamps, 0.8 of an amp, but put a little bit of voltage in it very quickly. 6.4 amps. Yeah, it's very surprising. So that leads me to our LED, which probably fell on the floor. There it is. How can we make this mimic a tungsten bulb so we don't get bulb errors? Well, first of all, this bulb takes close to 500 milliamps, 0.5 of an amp, so it's going to pass the hot bulb test. So absolutely no problem there. Put a little blip of current into it, and it takes absolutely no quick blip of voltage. It takes no current at all. In fact, I tested it earlier on. This has been modified now, so it's not going to pass this test. Yeah, it takes 40 milliamps. So the lamp control module says that's a dead bulb and gives you a side light warning. So what can we do to this to make it demand more current when it's first switched on? Well, first of all, it's got the first modification which we talked about, which was to make it brighter and pass the hot bulb test. So let's have a quick look at that. That's got a link between the two blobs, the two contacts. It's got a link there. It's also got a little device under it. Ignore that. Just have a look at that wire link that joins. Oh, we went into focus. And now we've gone out of focus. So yeah, it joins the two sides together. And so that although we only use the 5 watt terminal on our FTPs, it joins across to the 21 watt terminal and provides a lot of light, takes 400 milliamps, passes the hot bulb test. So that was modification number 1. Modification number 2 was to use a special device called a PTC, and that's a positive temperature coefficient resistor. Now, you've seen all the resistor kits you can get for cars where they've got massive great metal resistors. They have to be metal to dissipate the energy, and then you bolt them to the chassis of the car, and then they mimic, well, they don't mimic it very well actually, but they mimic a tungsten bulb. Problem is that when you're trying to mimic a 55 watt tungsten halogen bulb, for instance, then they're very low resistance and they get very, very hot because you have to dissipate something like 100 watts of energy to mimic the cold bulb test on a 55 watt halogen. So you end up dissipating huge amounts of energy. That isn't the worst thing. The worst thing is you have to fiddle about with the looms. And of course, the loom on an old BMW E31, E32, E38, whatever, they're crumbling. I mean, they start to disintegrate quite quickly. So never fiddle with the looms of an FTP or the pop-up headlights. It's a recipe for disaster. It is going to go horribly wrong. So 2 reasons. One, it's ugly, it makes a mess, you throw away a lot of heat, you might set fire to a loom. Secondly, don't touch the wiring, for goodness sake. The only time you touch the wiring is to change a bulb. Apart from that, ignore it and it'll stay okay. Start fiddling with, it's just going to break. Okay, so now what we need is a magic resistor, and I have a magic resistor here. And what the magic resistor is a resistor that sort of, yeah, we're talking about mimics again. It mimics a very low value resistor of fractions of an ohm. So it fools the LKM into passing the cold bulb test, and then it magically turns into not a resistor at all. It turns into something which has got a very high resistance, doesn't dissipate any energy. So yeah, it's a very clever thing, and it works a bit like a fuse. So if you can imagine a fuse, put lots of electricity across it, it demands a huge amount of current and then goes pop, and then it doesn't take any current at all. A PTC device is very much like it because they are used as fuses, and I use them in the electronics that I design to protect electronic components. So we've got a circuit with electricity going in. I go through a PTC, does all the work in the electronics. If something goes wrong with the electronics, the fuse open circuits, PTC open circuits, doesn't damage anything else. But the magic thing is when you turn the electricity off and back on again, it's mended itself again. Yes, a magic fuse that mends itself every 5 seconds. So, have I got a PTC? Right, here's the PTC. Now, this is a large one. It's too large for our purposes. But I'll pop one out. There we go. So this is a strip of them here. Where's my camera? There it is. So that's a strip of PTC devices. They're about 5 mil across and about 3 mil in the other direction. So yeah, they're PTCs, and we use a much smaller one. There we go. Here's a little strip of them. So there we go. They are much smaller. So they're the ones we're going to use. So what's the magic about these? Well, we can stick the probes again onto it and do a peak test. So I'll clear my peak. Let's see what one of these resistors actually demand when we stick electricity across them. So this is exactly what they're going to see, what the lamp control module is going to see. Yeah, I know you're excited, ready to go, ready to go. Okay, so you're not going to see my meter, it's too far away. Right, I'm going to short across. 9.8 amps, yeah, it's pretty amazing, isn't it? 9.8 amps, yeah, it's more or less mimicking a 1 ohm resistor. Yeah, it's taking a lot of current, isn't it? So that perfectly mimics the cold bulb performance of a tungsten lamp. Now let's see how much current it takes when it's warmed up. So I'm going to take it off of peak. There we go, that's better. We off of peak? Yeah, we're off of peak. So how much current does it take when it's just sitting there? Well, about 40 milliamps, absolutely nothing. Yeah, so that's a magic resistor. It's a magic resistor, there's absolutely no doubt about it. PTCs are magic resistors. They start off at 1 ohm, stick quite a bit of current through them, and then they turn into a kilo ohm or something like that, probably a bit more. probably a bit less, demanding 40 milliamps, so absolutely nothing, 0.04 of an amp. So there is a resistor. So instead of strapping a huge great lump of a resistor onto this chassis and mangling up your loom, use one of those tiny little devices. They'll pretend to be a 1 ohm resistor until the electricity's been through it for long enough. And of course that, because the lamp control module just sends a little pulse of electricity through it, it will fool it into thinking there's a tungsten bulb in there without stupid resistors. So anyway, what we'll do is we'll go back to peak. So here's a bulb I modified earlier. So this has got all the mods to it. It's got a PTC device on it. It's got the two connections joined together. And what we do is we'll quickly stick some electricity through it. So it's much easier to put that positive on and then flick across. Oh, be quiet. Here we go. One tip. Using probes, make them as sharp as needles. Makes everything a lot easier. Here we go. 4 amps. That's not too bad, is it? So that's nicely mimicking a tungsten bulb. And then when I'll take it off peak. There we go. Stay up there. Right, we're off peak now. See how much current it takes when it's actually running. Blimey, I've lost an eye. 0.5 amp. So there you go. That perfectly is mimicking a tungsten bulb. So which is why you don't get any errors on the mid. So that is simple as that. So it's 2 mods. Bit of wire between the pads, so it uses both sides of the element, and a PTC device which is soldered on the bottom there. I think I'll zoom in. You'll see this all later on anyway when I'm soldering it. There's the 2 terminals, there's the PTC. It's not hard work sticking on one of those, and then that is completely error free. You can just put it in the side light position and it will just stay in there forever and you won't get any errors. Well, I say forever. I'll put a little caveat on that, is that the PTC devices don't last forever. They're designed to be fuses, and if you've got something that's blowing fuses every 2 seconds, yeah, you're in trouble. So they'll have a lifetime of probably about 1,000 activations or something like that, and then they say, I don't want to be a PTC device anymore, it's no fun at all. And they'll just turn into open circuit, and then you start getting side light errors. But it's about 1,000 activations, and that's going to last you a few years. Yeah, I've had one which failed on the E31 and had to change it. But that's it. And the LEDs have kept going, apart from the original ones, which I got from super bright LEDs in the USA. They failed eventually because just the mechanical construction of them wasn't good enough. These are fantastic because they've got a metal enclosure. And of course they've got the LEDs at the end, 4 of them, which bung out the light forward, which is what you need on an FTP, because the actual reflector isn't much of a reflector. It's made out of black plastic. Shiny black plastic? Yeah, but it's black plastic. That's got to be 10 minutes up, surely. So anyway, so there we go. That was how to modify LED bulbs so they pass hot and cold bulb tests. Talked a little bit about wattage, voltage and currents and stuff like that, and we talked a little bit about these things which we'll do in another episode. They're meant to be 160 amps or watts and they're 5 watts, but very pleased with those. They told the truth. It was a 6-watt bulb. It demanded 6 watts of energy and it produced about 400 or 500 lumens of light, fantastically bright, and they look just as bright as the main beams. Of course, the main beams are focused. If you get in front of the main beam, it'll take your eye out. But the side lights chuck light everywhere, and they're very bright, and they make a car look a lot more modern. Okay, so we'll blurb on a little bit more when we talk about the main beams and how to make those error-free. You don't have to worry, they're not checked. And yeah, what I've got in there at the moment, I've got bulbs in there, had bulbs in there for ages that produce about 200 lumens of light. Bad news is you can't get them anymore. They've disappeared. I've had a look on all sources. Amazon, eBay, Alibaba Express, global sources. They've just disappeared off the face of the earth, which is why we're going to talk about those. Now, even though they just give out 5 watts of energy, well, dissipate 5 watts of energy, they bung out about 500 lumens, and it does come out in the right place. And of course, in the USA, you only use them to flash oncoming drivers, and they'll be perfectly adequate for that. But I'm not sure I'd be happy with those in the FTPs as main beams. But the good news is there's no messing about. It just goes in. Well, you have to file a bit off for those. Anyway, let's do that next episode. I've gone on for what, hours now? No, not half an hour. That's crazy. Anyway, yeah, let's go on how to modify the bulb, all in close up and lovely technicolor, and let's get on with it. Righty ho, we're ready. Got my bulb, LED bulb ready to go. Got a big lump of blue tack. Engineer's friend blue tack is perfect for this sort of thing. Now, the only problem I've got is the fact I've got 2 things missing. First of all, I've got flux missing because I burnt a hole through it with my soldering iron. Yep, turned the soldering iron on, it was on the flux. And I haven't got any tinned copper wire. So what I'm going to do is use some standard flex, and I've taken out 5 strands and I've twiddled them together. And what I'll do is I'll poke them into the flux. Yeah, very professional here today. I'm sorry about this. And then what we can do is we can use our engineer's friend, which is the blue tack, and we'll tin that. Not quite so easy to do. Now, of course, I've soldered stuff together with my soldering iron made out of plastic, because it absolutely kills tips of iron, plastic does. And anyway, what we'll do is we'll tin this wire. So put a bit of solder along the wire until it turns itself into a solid wire rather instead of braided wire. There we go. That's the way you do it. So that just makes absolutely sure that the twisted wire does take solder. Now, if you've got old bits of wire around, quite often they will not take solder, and that's because they've oxidized. Flux will help you out there if you had some decent flux. Rightio, the next thing we do is we just tin these contacts, just get rid of that solder. The reason for that is you want fresh solder on there. We don't know what the melting temperature of the solder which was put on there originally was, so just put a bit more solder on there. There we go. Then we use our tin copper wire. Solder it to that end first. Got my glasses on today so I can see what I'm doing. There we go, that's a nice blob. Solder it to the other side. Now, if we hadn't have reflowed these joints, it might be that we just can't melt the solder at this temperature. But there we go, that's perfect. And then just snip that to length. There we go. Right, that's the 2 terminals joined together now. So that will illuminate both sides of the LED. And remember, it's not sides in it's not as though it has a 21 and a 5 watt bit. It just actually tells the electronics to run at half power if you put electricity into that one, and full power if you put it into that. Joining them together just runs them at full power. So there we go, that's got our tin copper wire across there, or not tin copper wire as in this case. Next, our PTC device, our positive temperature coefficient resistor. Yeah, working with surface mount stuff when you're in your 60s. Yes, time to stretch a point, to be honest. But I work with them every day at work. Yeah, they don't get any larger, that's for sure. They get smaller and smaller. This one's quite a large size. This is a 1210 case size. And our stuff is usually 1206, which is quite a lot smaller. Rightio, so we get our PTC device into position, so nudging up against that. Don't forget, you don't have to do this stage if you're quite happy just turning the light switch on before you turn the ignition on. This only makes it error free at all times, if you see what I mean. Rightio, here we go, soldering iron. Plan is just to run it between those two. Not easy with something that it's at this size, but there we go. That's on. That's pretty nice. Turn it around a bit so I can get the soldering iron to the next bit. So we tin the other end as well. So there we go. That terminal is now tinned. Right. Next thing we have to do is join a little wire which goes to the body of the LED. Now, of course, the body of the LED is going to soak away the heat. So we've got to heat it up for a reasonable amount of time. And it can help if you just give it a file or a scraping. So we'll be doing it around about here. That helps sometimes, just to have a new surface. And then we'll put some flux on there as well. So scoop a bit of flux out of my ruined thing. Bit of flux on there. Soldering iron. I'll turn it to the side slightly so I can get my soldering iron in. All right, that's burning the flux. Now, if you just stick it on like that and take the iron straight back off again, that won't be soldered. You might get a blob of solder, but it certainly won't be soldered on there. There we go, that's better. So now we've got a good flow of solder. That is tinned nicely now, so we've got a nice blob of solder. Right, the next thing we do is we need to run a bit of wire from the PTC device to the, I'll get it the right way around in a minute, to that side of the bulb. So here we go, quick blob of solder on there. That's on. And then we'll turn that round so it ends up on the side there. We'll leave the wire long at the moment. Gives us a bit of control over it. There we go. So we've got it aligned right with the body. We can't leave too much of a blob of solder on the body because, of course, then the pins will be obstructed. So here we go. Remember, we've got to keep the iron on here a reasonable amount of time. Now, if you do get a blob, just file it off. Don't try and get it off with a soldering iron. You're hiding to nothing. Be fiddling about with it all day. Wait until the body heats up. That's the important thing. Otherwise, it's just a surface lump. There we go. He's on there. Snip the excess off. There we go. That's all done. We can check that it still works, obviously. Looks like I've left the meter on all day and night. There you go. And we're still in peak hold. So it'd be interesting doing a peak hold on that. Let's see how much. Remember, it's hot at the moment. And so, yeah, beep at me, go on. Here we go. So that came on and went off. Yeah, 3.4 amps, which is perfect. So that is now mimicking a tungsten bulb very well. I'll turn peak hold off. Let's see how much current it takes while it's running. Half an amp. So yeah, that is perfectly mimicking a 5-watt tungsten bulb now. Half an amp. Warm and a few amps cold. So yeah, that will perfectly mimic one of these little tungsten bulbs. That's a 10-watt, by the way, not a 5-watt, but I haven't got one here at the moment. So there we go, that's that done. Lovely job. There's my new one. They only go in one way, by the way, so try it that way. Doesn't turn, take it out, turn it 180 degrees round. There we go. He's in. Let's put him in the housing. Let's give it a go. Yeah, that's looking lovely. I'll whiz it up a bit so you can see. Isn't that great? That's fantastic, isn't it? Let's put the bulb in then. We've got some WD-40 and a screwdriver. Got the bulb in my pocket, so that's about all we need. Right. Right, yeah, it's a rotten day today, but there you go. So we start at the inside by the grill, wibble it up and down, till it comes loose. Do the same at this end, very gently. There we go, he's off. And you can see the clamps that hold it on. 2 screws, WD-40 first, just a little squirt of it on there. And you never put any force on these. If they don't start coming out, move them backwards and forwards until they're free. Now I had these off yesterday, so they're not tight at all. They'll come out with rust on the end of the screw. Now it's quite normal because it's not protected from the weather here. Yeah, they're all nice and loose. Otherwise, if you find any sort of force on them, just move them backwards and forwards. Work that oil into the threads. There we go, he's off. Get those out of the way, don't want to tread on. Right, and with these lights, they're held on with sticks which go backwards here. So once this is loose, this can all move. But if you just pull it forward, just snap the sticks off at the end. So what you've got to do is you've got to get your hand at the back here, and you've got to try and move it forward. There we go. There, he's out. Right, and the bulb we're after is here. I'm going to put him back in and get the bulb in my hand first, I think. So there's the LED we did earlier, all ready to go in. Right, he's out. Right, anti-clockwise and out. There's the old bulb. I'm going to get my leg wet here, I'm sure too. Right, old one out. If they don't rotate, take them out, turn them 180 degrees and try again. Right, so he's done. So he's got to go clockwise in, so we move him to around about there. Pulled him out of the clip now. And then clockwise. That's the connector there, that goes into that clip there. What we do is we make sure they go into the back there. Has to go in at an angle. Can't go straight in because it's got a little lump on the side of it. So it has to go in at an angle. And what you do is you never put any force on these. You just make sure it's going to move, and also make sure it's going to line up with the screw holes. What you don't want to do is have it so it's about an inch away and then try and screw it up, because that will damage the tabs or damage the pins. So make sure it's going to land, which it does. 2 screws. Probably best to check it works actually before doing this, but there you go. I'm keen, especially as it's horrible weather. It's freezing today. Damp and horrible. Right, and with the grill, start on the inside, wiggle it up and down. There we go, and do the same on the FTP side. There we go, check it works. Right, there we go then. Yeah, it's absolutely freezing, drizzling away out here. But I'm pleased with my FTPs. I love my FTPs. So thanks very much for watching. Oh, we'll do the main beams next, the FTP high beams, show you how to do those. Thanks for subscribing, and I'll see you next time. I'm going indoors. It's horrible out here.